the first part of this chapter, the notes are heavy and the homework's light. It really doesn't make sense to practice 10 telescoping series on a worksheet, because if you can do one, you can do 10. The biggest task for this chapter is when everything's mixed together. And we have to wait a while because we've really only done one type of series so far, geometric series test. There's 11 total. So, I mean, I could have you do geometric over and over again on a worksheet, but that's really not the issue. Like, they were kind of easy, weren't they? Yeah. That's each test in its day, except for maybe one of them. The integral test is kind of hard just as it is. But each test on its given day, you should be going, yeah, I understand that test. And to practice it over and over again really won't help you get any better at it. So I need to get some under your belt so that I can mix them together. Does that make sense? So the notes are kind of long today. We're going to do two different types of series today. Telescoping series, which is not on the AP exam yet. There used to be 3 that I did that weren't on it. Now there's only 1. They've actually, in the last couple of years, they added alternating series and they added what's called the limit comparison. Telescoping still has yet to appear on the AP exam, but we do it anyway. We cover all of them as if it was like just regular calc, not AP. And then we're going to do something called the Nth Term Test for divergence, which is the easiest one, as long as you don't apply it incorrectly. There is a homework here. It says 2A, 1 through 5B, but 2A spans the whole scope of all the tests. So if you don't want to have to do it all at the end, you could get this far today. It's on sequences, geometric series, Nth Term and Telescoping. It'd take about 10 minutes. There's not much homework I can give you yet. Even sometimes I suggest, if you're pretty good about studying, maybe you save this one till the end so that you practice them all mixed, but it's up to you. Does that make sense? So, yay, not a lot of homework, kind of boo, the notes are long. All right, so I'm going to get off of here, and we're going to hop onto your homework, and it looks like your next page is this one, isn't it? Sorry, mine's a little out. So it's just a quick recap. It's kind of like, why are we recapping we just started? Because there's already things that you might mix up. In particular, the difference between number 1 and number 2. They have different answers, and they're very different questions. And you arrive at those answers very differently. But it's the exact same rule of sequence. So, number 1 versus number 2, what is their huge difference? One's a sequence, which is a list of numbers, and one is a series. Correct? So, for the sequence, to converge or diverge is just about the limit. If it has a limit, it converges to that limit, basically, right? So this just says, let's take the limit as n approaches infinity of that rule of sequence. And you shouldn't need anything fancy to determine that. Your gut reaction is correct and expected. Correct? Because as they stand, they both go to infinity, but we can't L'Hopital it because we don't know the derivative of factorial. I talked about that's kind of ridiculous, right? But what does your gut tell you this is? It is 0. We've got that huge, powerful function on the bottom. This tells me that the sequence converges, and it converges to 0. If I were to start writing, and it'll go really quickly because n factorial is just going to kill that linear term on the top, so it's going to swoop down and go to 0 very fast if you were to start plotting dots. Like, it's going to really go there. But when you list it, you're going to continually be adding something that's virtually 0. Are we good? The next one, it says, does this converge or diverge? Well, the only test you have under your belt right now is the geometric series test. That's the only one. And that's not geometric. Right? Your gut might tell you, well, it converges, and your gut would be right. But that doesn't mean that everything that has a limit of 0 or every series converges. That's actually our big issue, is when you get 0, there's all these tests you have to run to decide. So for now, we don't know that one. Your gut would be right, though. It's not about whether it goes to 0 for the series, it's about whether it goes fast enough. So we're going to start off today's new notes with two of them, one that goes to 0 and another one that goes to 0. One converges and one diverges, just so you can see numerically how that happens. So it says, does this series converge or diverge? That's a series. If it was a sequence, you could answer that right now, right? What would you say? Converges to?
3 halves.
Yes, 3 halves. Its limit. Awesome. If what we're going to learn today with the nth term test for divergence, and it's what you're going to actually be running first, if the limit of that rule of sequence, I don't want to rewrite the whole thing, so I'm just going to go like that. And on ours, you said it equals 3 halves. You have to picture about what that means. It means that you're always going to be adding a half, 1 and a half, and 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 1 and a half. What does your gut tell you that will do? It does, okay? Because that is not 0. Just because it is 0 doesn't mean we converge, but if it doesn't, it's going to diverge. And that should make a lot of sense because you're constantly going to be adding stuff onto it. Does that make sense? So, but that's actually a new test. That's the nth term test for divergence. It's really easy. If your limit doesn't equal 0, the sucker diverges and you're done. If it equals 0, we have 9 more tests. Okay, so be very careful. And last step, when you look at this one, you should know this from yesterday. What kind of a series is this? It's the only kind you've been taught, but it's geometric, but not because it's the only kind we've been taught. What is it about it that makes it geometric? The a times r to the n. Exactly. If you see that, or I will tell you that if ever they ask what is the sum of this series, it has to be geometric. That's the only one, except for telescoping, which isn't on the AP test, that you can find the sum of. So if ever it says from here on out on an AP exam or on one of my tests, that if it says what is the sum of this convergent series, you're like, that's geometric. It might not look like it, like on the delta, didn't you have to play with it a little bit? But if it asks you for the sum, it is a geometric series. Then you should also know with the geometric whether it converges or diverges. Which one? Converges. Whenever you have a fraction, it's kind of like algebra 2 exponential decay. Remember doing a times b to the x? They said if b is less than 1, it's exponential decay. It's kind of the same thing. The only difference is ours is ar to the n, and this goes like that, and this goes like that, but it's kind of got the same thought process. So it converges, but you have to know why, because otherwise it's a 50-50 guess. Do you remember why? Thank you for saying absolute. That's one of those little details. There's 1,000 of them in this chapter. If you miss a ton of them, it'll take you from an A to a B. If you miss a few, I do halvesies. You know what I mean? So get most of the details, but you are right, Gunnar. You have to say the absolute value is what? Less than 1. We also should know from yesterday how to find the sum. That's what capital S without anything on it means. It's sum. Do you remember? A over 1 minus the common ratio. A is not this. Sometimes it is, like if I started at 0. But A is what you get when you put in the initial count. So be careful with that. Some people think A is always just that lead number because it looks like it from the model. Does that make sense? So make sure you plug that in. It'd be 3 times 4 25ths, or 12 25ths on the top. On the bottom, I have to do 1 minus, and it's r, not the absolute value of r. So it's 1 minus negative 2/5. So what's that, 7/5, right? 7/5, and then multiply by a reciprocal. I'm just going to dot it. So that's stuff you should know. Already a lot to know from the very tip of this section. Lots of new stuff. Nothing hard, though. All right. So the next thing I want to discuss is, sorry, I'm on the wrong page. Right in the middle here, by the way, anything highlighted means it's super important. If an example's highlighted, it means there's one like it on the test. I do that for studying purposes. I think you have to go find it. It's in the middle of the page. I think it's in the middle of yesterday's page. I did number the pages. So, did you find it? Nth term test. Yeah, it's before this. Sorry, I told you they're a little out of whack. So I'll give you time to find it. So the nth term test for divergence is what we call a one-way test. There's two one-way. Of the 11 that you're going to learn, 2 of them only are one way. Geometric is what we call two ways. You can tell if it converges or diverges with that test. This one only confirms divergence, but it's the easiest one and you should always in your head perform it first. Most of the time it'll fail it, but when it does work, you're done and you don't have to do anything fancy. What it says is that you take that limit and it's not 0. The function diverges. Not the function, the series. If we get a 0, that's the whole rest of this part of the chapter. All right, so be very careful. Every year I get 1 or 2 people who on our very first little mini test, they'll say that therefore S converges by the nth term test. And I'll be like, ooh, you can't make that conclusion. All right, so here's how you run it. You immediately in your head take a limit, right, of the rule of sequence. If it does not equal 0, we can draw a conclusion. If it does equal 0, for now, we're inconclusive unless it's geometric. So there's lots of if this, then that. This heads towards infinity. But it's not because it equals infinity that we say it diverges, it's because it's not 0. So you do have to put another little detail, like Gunnar said, the absolute value of negative. That's a little detail, but it's important. Same here, it's not because it goes to infinity, it's because it's not going to 0. All right, so then you'd say, therefore, I just am going to call this S, if you don't mind, so I don't have to keep rewriting it. S diverges. And you would say by the nth term test. I honestly like to call it the nth term test for divergence so that Lucy doesn't accidentally conclude something else. So maybe it's actually called the nth term test, but I like nth term test for divergence. So look at the next one. Quickly in your head, run a limit. What is it? 0. This is inconclusive. You do not say it converges. All right, we don't know yet. This actually diverges. It's one of the most prominent series. It's called the divergent harmonic. It has something to do with the music tie-in, and we're going to be using it a lot. But it actually diverges, and we'll show you later in the chapter. So this is inconclusive as of now. I don't know. Now you might say, I don't know how to find the limit on this one. You don't technically, but you do. So think about, we've been talking a lot about growth. What does your gut tell you that limit would be? I'm hearing primarily 1/3 and a couple little zeros in there. The bottom is bigger, but do you see how I've got tied power function families? Kind of like if it was 3x cubed plus 4x over 4x cubed minus 11x squared plus 99, right? What's that guy's limit? 3/4 because the thing in control is tied. So the 1/3, you were right, okay? Now, what will I write next? Does not equal 0, therefore, and then what would I conclude? S diverges, and you're going to eventually have to say by what test, because there'll be 11. So you'd say by the nth term test. All right. So this says determine whether the series converges or diverges. If it converges, find the sum. What are they telling you about at least one of those? It's geometric. That's the only one we can find the sum. Does that make sense? So it's a good trigger. You guys are listening. So can we just talk them through? Let's begin. The first one, when I take a limit, because that's what you're going to do in your head. And you're going to go, and honestly, as the chapter goes on, you're going to go, oh, sweet. This I get to be done. You love this test because it's done in your head and you don't have to run through a hierarchy of others. So this one's got a limit as n approaches infinity of what? 2/3, which doesn't equal 0. Therefore, series diverges by the nth term test or divergence. It's not hard, but wait until it's mixed in with all the other ones. All right, so let's go take a look at this one. Letter B. Those of you listening at home, they're writing it, I'm not. I'm just sort of I want you guys to write out B, and then maybe we'll see what you wrote. Multiple choice, bam, go circle your answer. FRQ, you've got to have your poop in a group because they give a point for everything. Student identifies correct test. Student has hypothesis of test. Student makes correct. They really pick it apart. Multiple choice, though, it'll say which of these does not converge. It'll be something like that where you have to run the tests in your head. Did you get it, Connor? What did you write on your paper? Let's pretend it's a FRQ.
I said limit of n factorial over 2n factorial plus 1 as n goes to infinity equals 1/2. And then 1/2 does not equal 0, so it diverges by the term test.
Perfect. Okay? Perfect. The next one. Let's run a limit. And again, I put one of those exponential functions in here because, just a second. Go with your gut. If your gut you think is solid, or L'Hopital, and the 2 goes away. That's why those non-powerful things kind of just leave your brain. Does that make sense? Especially those constants. Really, what do you think this is? 1. If I had to L'Hopital it, it'd be ln 3, 3 to the n over ln 3, 3 to the n, boom, boom. But if they test you on L'Hopital's rule, it will not be embedded in a series. So just confirm to yourself that this is 1. Then what do we write? Does not equal 0, therefore. Now this guy, letter D, my gut tells me it converges. Here's why. For sure the limit's going to 0, correct? So it fails the nth term test for divergence. So I need another test. The only one I can find the sum is in the geometric. I must be able to write it like this. You might say, well, what's up with that decimal? I hate it. So I'll get rid of it. What is 1.1 really? 11 tenths. Okay? So this is really the sum as n goes from 2 to infinity of 1 over 11 tenths to the n. Well, we need to multiply by a reciprocal. So I'm going to erase that if you don't mind. This is really 10 elevenths to the n. Now it's in geometric form and I have a conclusion and I can tell to what it converges. Blake, you're nodding, right? It's a very new weird stuff. This is a weird chapter. It's so different. It's the 4th pillar. I've always said there's 3 pillars of calculus: limits, derivatives, and integrals. There's actually a 4th, but it's series. But the other series doesn't get used again outside of series. All right, so right there, converge or diverge? Yes, but we have to say why. All right, so the series converges, and you're going to say what Gunnar said on the last one. The absolute value of r is less than 1. But you're eventually going to have to say by what test? So you're going to say by GST. I'd probably swap those 2 phrases, but whatever. Now for the ones that do converge, so basically the geometric, you'll have to say to what? So what do I do to figure that out? A over 1 minus r. You did that yesterday, so we can just leave that off. But you would have to say to what it converges. So now let's go. Is this your next page? Man, I kind of out of whack. I dropped my file and we put it back together. And it's lots of papers. All right, so now we're going to start a new one. Look at this guy. It says, does this converge? Well, the first thing I'm going to do is run that nth term test. I'm going to take a limit really quickly, right? What's my limit as n approaches infinity of my rule of sequence? 0, right? So inconclusive, I need another test. That thing is not geometric, right? And that brings us to our 3rd test. We're at 3 out of 11 after today, all right? So let's expand it to see what happens. Watch what happens when I write this out. I get 1 over 1, which is 1, minus 1 over 3. That was exciting. I just want you to see what happens and why it gets its name. All right, and then I put a 2 in, and I'll get plus 1 over n minus 1 over n plus 2. So far I'm going, that's a lot of arithmetic, but I'm going to keep going and you'll see what happens. Then I'll do a plus 1/3 when n is 3 minus 1/5. And then I'll do a plus 1/4 when n is 4 minus 1/6. And then I'll do a plus 1/5 when n is 5 minus 1/7. What are you noticing as I'm writing it out? It starts going like this. Things start canceling. That's why they call it telescoping. That actually down to just a very small. You have smiley eyes today. She's smizing. Are you happy, Pal? Yeah. Good. She's got smiling eyes. I love when I look up and I see smiley eyes and good eyes. Why are you happy?
I don't know, I'm in a good mood.
Good. My son called me and he was super happy. He's 24. He won $5,000 in some NCAA bracket something or another.
Oh, wow.
Yeah, something. I'll have to ask him what it was actually. Does that sound right? NCAA bracket? I don't know. Whatever. I was like, $5,000? How much did you put in? And he said 40. I was like, well, I guess that I was going to yell at him. Anyway, where was I? Oh, back to telescope. Here, this is, Kelly got me off track with her smizing eyesies. Watch what happens. Gone, 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 gone. Will 1/6 eventually go? Yeah. Everything's going to go, but look at once it started. Do you see how the first one to go was this one? Anything with a smaller denominator will stay then. Does that make sense? There's no way I can get rid of the plus 1/2 when I keep introducing. You get it. So what is that? 1 plus 1/2 or 3/2. I have no clue what I meant to put in this rectangular box. There. So, I don't know. Anyway, so we call that thing a telescoping. Series like that, where gone, 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 gone. That one's 1, right? They're called telescoping, and they need to be expanded. Now, one of these looks like it's set up for telescoping. The other two don't. Why did I highlight letter C? I'm going to put one like that on your test. All of these have limits that go to 0, so every single one of them fails the Nth Term Test for divergence, right? None of them look geometric at all. Like, geometric will really stand out to you because it has such a recognizable format. So this guy looks like I'll be subtracting stuff and getting rid of stuff, but I have to start, okay? So you just start plugging it in. When I put in a 1, I'll have 1/3 minus 1/5. When I put in a 2, I'll have 1/5 minus 1/7. Guess what the answer is? 1/3. Everything else will go. If you don't trust it, keep writing it out. Like, if you don't trust me. But I think by now we trust me most of the time, except when I'm in a weird mood, right? If you kept doing this, I mean, will minus 1/7 eventually cancel? Yeah, when n is 3. So, 1/3. Done. This series converges to 1/3 by the telescoping series test. It's done. Now the other two also have limits that go to 0, so I don't know if they converge or diverge. They can be done actually with a couple tests, but you could do telescoping test on this. What do you think you need to do though? This one, yes, I'll need to factor over here. So somebody said factor. You're right on letter C. Yes. I'm going to write that. Thank you. N plus 1 times n plus 3. All right. How do you think I'm going to be able to write it as a difference or sum so that things start to disappear? Decomp. Did you hear her? This has got partial fraction decomp if you want to get it to telescope. So, we need to take 1 over n times n plus 1 and write it as a over n plus b over n plus 1. There is a shortcut for this, but it's too dangerous. first 5 years I taught it, and I always had too many try to use it. I feel bad for the 10 who could do it, but Google the heavy side method, and it's heavy with an I, Heavi side. But this is just safer, so go ahead and do it. You should remember how, right? The numerator equals this times this plus that times that. Why are we high-fiving?
I drew him as a snake in the box.
Oh my God.
Thank you for putting the box.
You're welcome. I'm glad I could entertain you, my little ADHD child. Oh, good Lord. Anyway, I want you to go find the A and the B. I actually do think I want to show you the shortcut. I'm going to. Be very careful. Beware. The first couple times you use it, double check it. Okay? But we like shortcuts. As long as you can do it the long way, I'm good. But multiple choice is actually pretty helpful. I'm going to say it twice. And then you'll know if it's stuck. If on the one you do on your own, you can apply it correctly. If you can't, revert back to this. Okay? So the shortcut can go right to here. And I gave you enough. Did I give you enough time to find A and B?
Yeah.
Yes? Okay, otherwise I'll wait a little longer. But it go, bless you.
Thank you.
I'm going to do over n and over n plus 1. And I'm not going to put the A and the B on the top. I'm going to get it right away. And this is what you do. You cover up, and those of you at home, you can't see me, but I'm covering up for them the n with my finger. So I'm actually, for people at home, I'm going to go like that, okay? But you cover that one up, and you say, what makes n 0? Here, let's go like this. What makes n 0? 0. You put it in for the other one. What do you get when you do 0 plus 1? That's what goes over the one you're covering up. Did I lie? Was your A 1? Okay. Now watch. Now you gotta watch carefully, and you have to be able to retain it. I go to the other factor and I say, what makes that factor equal to 0? I cover that factor up. For people at home, I'm going to cross it off. And I put negative 1 in for the other factor. What did I get? Negative 1. That really made me nervous. Every year I say I'm not going to do it, but I hate doing the A and the B embedded in a different question. And I never told you it when we were in that chapter, but there's really what it really speeds up this series part of it. So our count has to start at 1. Remember, for sequences, it always starts at 1. Series, sometimes it's 1, 2, 3, 0. All right, and you go ahead and write it out. Get it to collapse, and tell me to what it collapses or telescopes to. No, we're going to finish this second letter B off here. Then we'll do C together and 1 on your own, and we're done. I think there's only 1 left on the next page. I just want you to manipulate pieces of them on your own, and then we'll do a full one on your own. What was it? 1. So if I were to say take out your calculators, and I do think let's do this, let's do it on the next one. All right, because 1 is boring. All right. So when I look at that one, I actually run a different test in my head. But telescoping is an option for this because the bottom factors, and I could try to break it apart, right? Now let's see if you've got that. I'll talk through that heavy side method for you one more time, okay? It says n equals 1 to infinity of 1 over, oh, I already wrote it again. Oh, well, let's write it another time. Let's start over. All right. Sum, n equals 1 to infinity, 1 over n plus 3 times n plus 1 equals something that I'll do in my head over n plus 3 plus something over n plus 1. It starts with leaving the A and the B off, and it starts with you coming in with your fingertip, picking one of the factors, and I'm going to pick n plus 3, and as you're doing it, you ask yourself, what would make this 0? And you say what? Negative 3. Where did I say you put it?
In the other one.
In the other one. Okay? When I put a -3 in the other one, I'll get a -5. You with me? 2 times -3. Oh, sorry. Oh, my bracket looked like a 2. I lost. Sorry. My bracket looked like a 2. All right. So -3. And those of you at home, I'm holding my hand up so they can't see it. So that's kind of like a bummer. Do it the A over B method if you're distance learning. All right. When I put in a -3 right here, I get a -2. That goes over the one you're holding up. That's the biggest mistake of kids. Like 2 weeks from now, kids are going to actually forget where to put it and they just throw it in. So be careful with that. For the other one, I'm coming in from the right-hand side with my hand. As I do so, I say, what makes this factor 0? And you say -1. And put it in for the other one. And where do I put it? But it'd actually be a half, sorry.
Okay, that's what I was wondering.
Oh, yeah. Yeah, because of the 1 on top.
Okay.
Now I would reverse them because I don't want to start with a negative. So if I were you, I'd write it with a +1 first. And then the -1.
Girl, this is not a shortcut.
Oh, it is. If you don't screw it up, right? Then what do you think I'd suggest you do? Yes, but I wouldn't do that. I would do something though to not be working with that a half.
Do it 2
Yeah,
to the
multiply the whole sum by a half so you can get 1s on the top. So whatever we get when we telescope, we're going to keep in mind that we actually have a 1/2 up front. N equals 1 to infinity. Woo, this is fun.
Yeah.
All right, now you guys go crank her out. I'm going to put that 1/2 down here just because I'm afraid I'll forget about it. I will have a 1 over 1 plus 1. Next up, minus 1 over 1 plus 3 plus, yes, 1 over 2 plus 1 minus what? 1/5. Now I'm at n equals 3. And what do I get? And then I would stop because I've got my first collapsing. And what did I say? Every denominator under that will never disappear. If you don't trust it, keep writing it out and you will get a plus 1/5 when n is a 4. See, that can go, but the 1/3 you can't get to go. Common sense. All right, so really what I have is 1/2 of 3 plus 2, 5/6. 5/12. This is the one I do. We're not going to do this one. I want you to check this by going back to the original on your calculator, because we've stayed off your calculator today. Let's go back to this original one. What calculator command does these? Math 0. I want you to math 0 it to my new favorite. Let's see if it'll take 999.
It took my thing forever to load the other day.
Then do 99. Depends on your calculator. $999 is my favorite, but sometimes your calculators say overload if things get too big anywhere or too small anywhere. What did we get? Math 0 from 1 to 999, 1 divided by 0.415668. Can someone back that?
Yeah.
Now do 5/12 on your calculator. What's 5 divided by 12? Is it pretty darn close? 4 point. It's very, very close, isn't it? They're actually matching up to the, is that 100,000s place? Yeah, so we're going to eventually be finding error with some of ours. So this is great. Awesome. So before we leave for the day, what's your homework? Nothing. What can you do? You could do 2A, 1 through 5B, you have enough information. Okay? I want you to go try this one. Everybody on their own. Go try the next one if you want. Go try before you take your test. That's what I do.
Yeah.
I will smack you, boy.
I'll forget
Actually, you just like slap me across the
Okay.
face.
Does that get it?
We still have 15 minutes left, but you guys hung in with me for a while, so
Yeah,
just
I
do
know.
this one on your own.
I know. We're gonna go like this one. It was
Yeah, we never did, because you were gone yesterday. Hide this.
I was gonna say I got some things. The distance learners had it. Yeah, I'll get it. I'm gonna let you guys finish this.
No, I don't like it. Because you're not so. I like it. It's kind of snazzy.
You can still do it. Yeah, I bring the 4 out front before you even start.
Well.
Let's go. I was actually smart about it.
It's kind of like derivatives and integrals. If you get the constants out front, it sometimes makes your arithmetic. Those of you at home, they're trying this one on their own, and I suggested, I was talking to somebody in the middle of the room. I suggested, just like with derivatives and integrals, to pull that 4 out front, but don't forget about it. Like I maybe go drop it at the bottom of your page and like 4 through.
Because it's still like 1 over n.
Yeah, I just put the one. So then you can pull the third out front. Yeah, I already have that. So then if you started there. Good job. Then
Oh, so you have to divide it over. Because there's always something to say that. I have no idea.
And then you can take out the one first.
You're my only hour and my first.
Oh,
right.
Yeah, then you take
I
out
just
the.
thought.
then we started at any with 0 and we go for it.
I was like, I'm not.
I have no idea what the right answer is until I see some. I do not remember it from last year.
4.
You start at 0. No. Start with
Oh
the 0.
my God.
So 1 minus 1.
Did not go that far. I just don't think I had.
7. Okay.
Those of you who are done, math, zero it and see if you're, because I don't want to put an answer out there, especially for the distance learners, that's not right. So if you're done, go check it. Somebody who checks theirs and their fraction matches up. Go to 999 or 99.
We got the same. You added on?
I definitely didn't get what you did.
I got what she got.
Really?
Yeah.
What'd you get?
I got 22.
Yeah.
I think I got that.
Let's go.
Oh, you're right.
I got
Oh my gosh, I actually did.
All right. I've got 3 over there with the 22 ninths.
That's right.
If you didn't get that, fight it out with someone next to you and make sure you know how to get that. I'm going to pass out 2A. You can completely ignore it or
I like that.
I like that.
get a start on it. There's no due date for this yet. It's not even next week.
Oh,
If you don't get the 22 ninths, keep working it. Makes sense.
I skipped right over it. I went from 0 to 2.
It's just a 1/3 and a 1/3.
Be correct.
Even
I got a negative number.
You might want to go back to the homes a little bit.
I'm so happy.
Oh, Camilla.
What's going on? What's going on?
Somebody cover that.
I just
Yeah, I would. Or double check it.
You're supposed to get 1/3 on top, so then it would be 4/3 out.
Got 22 nine.
Yes.
Okay.
I got a bunch of stuff.
Don't forget you have a
Oh, yeah.
So then I want to add 1/4 again.
So that's where everything will start.
So would it just be 1/3, not the negative? Yes.
Yep, and one for that, and then for that.
So I do all negatives.
Is that a negative?
Yeah, that's a negative.
Great. Then I think
I
we
wish
have
I could see it.
Samesies. We love doing algebra.
Sorry guys at home, they're just working on